Hello everyone, I am Ninu Francis, Assistant Professor in Computer Science and Engineering Department of Jyoti Engineering College, Cheruduruthi, and I welcome you all to our online learning platform. Now moving on to the topic, RTOS based design. RTOS means Real Time Operating System. Okay, all of you know what is an operating system is. An operating system, it acts as an interface between the hardware and the user. We can also say that it acts as a bridge between the user applications or task and the underlying system resources through a set of system functionalities and services. And we know that the operating system, they provide different types of services like the process management, memory management, input output, file system management, then memory management we have already said, right? So there are different types of services that the operating system gives. And now we move on to the operating system services in detail. The first one is the OS goals. The OS operating system goals, they are the perfection, correctness, portability, interoperability, and providing a set of common interfaces for the system. And they also provide the access and the control when managing the different types of processes. It includes the management of processes, then the scheduling of the processes, and defining the common set of interfaces, everything. So it deals with the perfection, correctness, portability, interoperability, and providing a set of common interfaces for the system. And this constitute the operating system goals. And now the second one is the mode structure. That means there are two processor modes. They are the user mode and the supervisory mode. And when the mode is in the user mode, by a user function call, it is not at all permitted for reading or writing into the protected memory. Means the protected memory, it is always having some privileged functions and they can be operated only in the supervisory mode. Okay, that is a privileged mode. But in the case of the user mode, we cannot access the protected memory because the user function call, it is not at all a system call. That is the reason. Okay, and now the second mode is the supervisory mode, which means that the protected memory and the privileged functions, they can be accessed only in the supervisory mode. So the OS, it can access the hardware resources and protected memory, and using a system call we can access it. It is only possible in the case of the supervisory mode. So the two modes are user mode and supervisory mode. And now the third one is the system structure. It means that the operating system, when it is connected with the hardware and the user applications, they provide a layered model. There is a layer structure. It means that the underlying hardware, okay, it consists of different layers. They are the underlying hardware and the device driver interface, and the next we come across the kernel. Okay, and it has the actual portion is the operating system, and in that the operating system we have the kernel, and the kernel is the core of the operating system. Okay, and they offer certain services which we have already said, that is the memory management, process management, file system management, input output management, everything they are offered by the kernel. And next we have the application programming interface, API, through which the user applications interact with the OS. Okay, so this is the layered model. The operating system, when connected, it consists of a layered model which comprises of the underlying hardware, the hardware OS interface, OS itself, and the application programming interface, and the application software, which is the user application. So this is the layered architecture. Okay, and now the fourth one, that is the kernel. We all know that the kernel is the core part of the operating system. and it is responsible for managing the system resources and the communication among the hardware and other system services. Okay, so the kernel, it consists of certain management interfaces. That means uh, the file management, device management, everything. So it is a basic structural unit of any OS. Okay, it does everything, and the kernel is, it can be defined as a secured unit of an operating system also. Okay, and all the functions, they are given by the kernel. Okay, so this much about the operating system services. And now we move on to the real-time operating system. Of course, it is an operating system in which it is having some hard real-time or the soft real-time constraints. Okay, we have already said there are different types of operating system. There is a general purpose operating system as well as a real-time operating system. In the case of an RTOS, we have some real-time constraints, and the real-time can be hard real-time or the soft real-time. The real-time constraint means the constraint on the occurrence of an event and the system expected response and latency to the event. Okay, so this is in the case of a real-time operating system. That means in the last portion we will discuss in detail about the hard and real-time constraints. Okay. And now we move on to the examples: Windows CE, QNX, then VX, Work, Micro COS. All these are examples for the RTOS. And now we are moving to the real-time kernel. Okay, real-time kernel means the kernel of a real-time operating system. It is referred to as a real-time kernel. Okay, and there is a difference between the real-time kernel and the ordinary or the conventional operating system kernel. That is, the real-time kernel, it consists of only the minimal set of services that is required for running the user applications or the task. And the basic functions of a real-time kernel are task or process management, then task or process scheduling, task or process synchronization, error or exception handling, memory management, interrupt handling, and the last one is a time management. Okay, so these are the different functions of a real-time kernel. And now we move on to each one of them. The first one is the task or process management. Okay, as the name implies, it deals with the management of the processes. Okay, and it deals with the setting of the memory space for the task. Okay, and we need to allocate the system resources for the completion of the task. And the major task is to set up the task control block, that is a TCB. Okay, TCB, it means it consists of certain information corresponding to a task. Okay, and now we're going to the details. A TCB, it usually contains some information regarding the task. The first one is the task ID, means the task identification number. And the next is the task state. It indicates the current state of the task. We know that there are different types of states. For example, if the state is ready, then it means that the task is ready to execute. Okay. And now the next field is the task type. It indicates what is the type of the task. The task can be hard real time or soft real time, or it can be any background task. So it indicates the type of the task. And now the next one is the task priority. We can prioritize the tasks, and if it is having the highest priority, it will be done first. And we can set the priority as the task priority equal to 1. Okay, and now the next one is the task context pointer. Okay, so it is a pointer for context saving, and we have another pointers such as task memory pointer. Okay, these are the pointers to the code memory, data memory, and stack memory for the task. And we have another pointers too. They are the task system resource pointer. These are the pointers to the system resources used by the task. For example, the semaphores, mutex, etc. So, for the system resources, we are maintaining some pointers. That is a task system resource pointers. And there are pointers to another TCBs also. So, there will be many different task control blocks, and each one of them will be interacting with other TCBs, and for that we maintain the task pointers. And there are another relevant task parameters also. So all these contains, it is included in the TCB. So the TCB, it means it is holding certain information regarding the task, which include the task ID, task state, and there is a task type which indicates the type of the task, and next we have the task priority, indicates the priority of the task. If it is high or low, we can set accordingly. And it consists of 4 types of pointers also. The first one is the context pointer, then the memory pointer, system resource pointer, and the task pointers. All these are included in a TCB. Okay, so this is done by the task or process management. And now the second task, second function is the task or the process scheduling. Okay, as the name scheduling, we know that, isn't it? So it deals with the sharing of the CPU among various tasks or processes. So there will be a scheduler which handles the task scheduling. It will be an algorithm, right? It will be an algorithm which perform some optimal scheduling of the task for the system performance, for the high system performance. So there will be different types of scheduling algorithms also. So that is the second one. And the third one is the task or process synchronization. Okay. So there will be some resources, they will be concurrently used by the different tasks. So we need a synchronization between them. And this is a service that is offered by the process synchronization. It deals with synchronizing the concurrent access of a resource that is shared among multiple tasks, and it also handles the communication between those tasks. Okay, and now the fourth one is the error or the exception handling. It deals with the handling of the errors or the exceptions which are raised during the execution of the task. And these errors or exceptions, they can happen at the kernel level service or at the task level service. For example, deadlock. It is an example of the kernel level exception. Okay, and there is another one called the timeout. It is a task level exception. It is specific for a task. And there are other exceptions also, such as deadline missing or divide by zero, everything, or insufficient memory. All these are examples of errors or exceptions. Okay, and the operating system, they gives the information about the error in the form of a system call. Okay, now we move on to the memory management. Okay, so in the RTOS, it makes use of the block-based memory allocation technique. Okay, instead of the usual memory allocation technique used by the GPOS. That means fixed size of dynamic memory blocks are allocated to a task on the need basis. Okay, and these blocks, they are stored in a free buffer queue. Okay, so the difference between a GPOS and RTOS is that in RTOS, the RTOS kernel, it uses the blocks of fixed size of dynamic memory. Okay, fixed size blocks are used and they are allocated to a task on a need basis. And so that we can avoid there are certain memory fragmentation issues will be there. Okay, all those things we can avoid in the case of an RTOS. There will not be any fragmentation issue or a garbage collection overhead these two things will not be there in the case of an RTOS environment. Okay, because it uses a fixed size block memory allocation technique. And in some RTOS kernels, it implement virtual memory also. Okay, and for the memory allocation, it uses the virtual memory concept also. So this comes under the memory management. And now the next link. Okay, we know what is an interrupt is. Okay, what is an interrupt? An interrupt which will inform the processor that an external device or an associated task, it requires the immediate attention of the CPU. Okay, there can be some hardware or software signals which is given to the processor. Okay, and the interrupts, they can be of two types, either synchronous or asynchronous. The first one is the synchronous interrupt. These interrupt, if they are occurred in sync with the currently executing task, we can say that it is a synchronous interrupt. Okay, so for example, divide by 0, then the memory segmentation error, all these are examples of the synchronous interrupt. Okay, synchronous interrupt means usually all the software interrupts, they come under the synchronous interrupts because they are occurred in sync with the current executing task. Okay, it is specific to the task. Now the second type is the asynchronous interrupt. And this type of interrupt, they can occur at any point of execution of any task, and they are not in sync with the currently executing task. Okay, so this type of interrupt, they are generated when some external devices are connected to our processor or the controller, and if there is a mismatch between the communication or and anything, so it includes the timer overflow or the serial data reception or transmission interrupt, everything that comes under the asynchronous interrupt. Okay, so there are two types of interrupt, synchronous and asynchronous interrupt. Synchronous interrupt means they are occurred in sync with the current executing task. And if it is not done, then that type of interrupts, they come under the asynchronous interrupt. Okay, in the case of an asynchronous interrupt, the interrupt handler, it is usually written as a separate task. Okay, then, and if an asynchronous interrupt occurs, a context switch happens in order to run the separate task depending on the OS kernel implementation. And also we can set the priority levels. Okay, and the interrupt handling, it will be explained later. And with this much, we are concluding the interrupt handling. And now the last one is the time management. Okay, the time management, it means the accurate time management, it is necessary for providing precise time reference for all applications. Okay, so here we are using a high resolution real-time clock hardware chip, and this RTC, this hardware timer, it will provide the time reference to the kernel. And the hardware timer, it is programmed to interrupt the processor or the controller at a fixed rate. Okay, and this timer interrupt that is given by the hardware timer, it is referred to as the timer tick. Okay, and the timer tick is taken as the timing reference by the kernel. And the timer tick interval, it may vary according to the hardware timer. So the thing is, it will provide the timing reference to the kernel. So we have in this class, we have discussed what is an operating system and the operating system goals. There are 4 operating system goals, OS goals, processor mode, system structure, and the kernel. Okay, and next we have discussed about the RTOS and the basic concept and the basic functions which are offered by an RTOS kernel. Okay, thank you all. With this much, we are concluding our first video. Okay, thank you.